Well, in the earlier examples that we've been doing with these combinations, these compositions of sine, cosine, tangent functions and the arc sine, cosine, and tangent functions, what we've stated so far is that, well, we just work from the inside out. But what if this is not a common angle, right? I mean, what angle is it whose sine is exactly equal to 1/4? Well, that's not one of those exact values. So we need to take a little bit of a different tack here. In this case, let's look at it. Arc sine of 1/4. The way I think about it is that there's got to be some angle theta whose sine is equal to positive 1/4. So what could we say? Well, first of all, whatever that angle theta is, it has to be between negative pi over 2 and positive pi over 2. And it has to be a right triangle whose ratio of opposite to hypotenuse side is a ratio of 1 to 4. So there's some angle theta that arc sine is what we're going to get. So theta is the arc sine of 1/4. Now, I'll tell you, you don't need a calculator to do this. I mean, conceivably, you can take your arc sine of 1/4, find the angle, and take the tangent of that angle. But a much better tactic and a more useful one in terms of calculus is to do the following. What we're really saying is that we're taking the tangent of that angle, whatever it is. So it doesn't really matter what the angle is. What matters is the ratio. So what's the ratio? Well, all right, let's figure it out. Here's x. We don't know what x is, but we know that if we squared x and we squared 1, we would get the square of 4. Which is to say that x has to be the square root of 15. And not only that, when we take the tangent of that angle, we're going to get 1 over the square root of 15. So the tangent of the arc sine of 1/4 is the same thing as saying the square root of 15 over 15 when we rationalize that expression. Very clever. All right, let's try this one over here. We've got the cosine of the arc's tangent of negative 12/5. What could we say? Well, arc tangent is going to give us an angle between negative pi over 2 and positive pi over 2, whose tangent is negative 12 to 5. So that means that we've got this right triangle somewhere here in the fourth quadrant, right? Because that's where tangent gives us negative values on that interval from negative pi over 2 to positive pi over 2, not including pi over 2 and positive pi over 2. And the ratio of those two is, let's see, negative 12 on the opposite side and 5 on the adjacent side. This looks familiar. So there's some angle theta here that we're taking the cosine of. So that means we would want to know what the hypotenuse was. Well, if we know what our hypotenuse is, let's see, h squared is equal to 5 squared plus 12 squared. Let's see, that's 25 and 144. H squared is equal to 25, 144 would be 169. Nice perfect square. H is equal to the square root of 169, which is to say 13. So the cosine of that angle is going to be adjacent over hypotenuse, 5/13. So the cosine of the arctangent of negative 12/5 would be 5/13. All right, and it's a positive number. How about this one? Sine of the arc cosine of negative 7/25. Well, all right, let's go at it. Negative 7/25. So remember, this is arc cosine, so arc cosine has to be an angle somewhere between 0 and pi. So in the first or second quadrant, and in this case that means we're in the second quadrant, there's an angle whose cosine is ratio negative 7 along the adjacent side to 25 along the hypotenuse. So whatever that angle theta is, that's going to be our ratio. So we're going to be taking the sine of that angle theta, which means that we have to get the length of the opposite side. Call that y. So what do we say? Well, negative 7 squared and y squared y will be a positive number, is equal to 25 squared. Let's see what we can figure out. Well, this is 49. Do a little bit of math right here. This is 625. So we're going to subtract 49 from both sides to get y squared to be equal to, let's see, 625, carry the 5, 15, 9, that's 6. So carry that 161 minus 4, that would be 576. Aha, another perfect square. 576 is this, happens to be the square of 24. All right, so that means y is equal to 24. And so if we wanted to take the ratio of opposite to hypotenuse, that would mean 24 over 25. And so the sign of the arc cosine of negative 7/25 is the positive number 24/25.